I was assigned by QE to GB Hospital to design and produce a wearable device which would allow and assist the hospital's employees. A wearable device is a device that can be worn and interact with the user. The device should cover a single common problem at the hospital facility. Designing the device will be approached using design techniques like explore, develop, and generate phase. Provided was 2 appendixes. The first appendix being issues revolving around Tammy, who was a nurse. She provides a list of issues and her needs and wants. Hobbies / interests that Tammy could provide are socialization, creating videos, and singing. The second appendix is a doctor by the name of Vincent. He provides an insight to issues which revolve around his work, as well as his needs and wants. Vincent often likes to play video games and likes to cook. Tammy dispenses a list of problems that lie under 2 factors: inability to have attentiveness and direct communication with patient. Attentiveness problems are nurse being persistently occupied to provide attention to other patient, retrieval of vital signs of patient, limitations of buzzer distance. Problems that resonate under communications are when patient leaves room / bed, often they do not respond to calls, not being able to track patients once they've left the ward. Needs and wants of the nurse are simple, retrievable vital signs, and ability to effectively communicate with patient. Vincent provides problems that corroborate with Tammy's problems. One major factor that covers Vincent's issues is communication, which range from patients to work members. Issues that revolve around communication, work members' inability to directly communicate with them. No update response to pages assigned by doctor. He also has the inability to directly communicate with patients, which can lead to large consumptions of time. He struggles to locate patients if they were to leave their beds. For example, victims of dementia tend to leave their beds. The second major factor is determining the condition of the patient. Issues that lie under this factor are the vague insight into symptoms of patient and no consistent medical record. One of Vincent is a respiratory monitor, which is a vital sign that would be assisting in determining the symptom of the patient. Devising of ideas was a design process that was utilized before the low fidelity prototype. Existing designs also interpreted inspired by the final design. I chose a design that would assist Tammy in retrieving vital signs from patients. I designed a wristband-like device that would monitor heart rates. Patients will be able to use the wearable device to apply on themselves to receive circulatory rate, essentially allowing Tammy to retrieve vital signs without having to apply a user rate monitor on patient. The design is useful, as it saves the nurse a lot of time and allows to provide more attentiveness to who require more attention / treatment. CARP is an acronym standing for contrast, alignment, repetition, and proximity. My design is a full block wrist strap, which is simple and not too appealing to the eye. Components are hidden under the strap where the user cannot see, and the components provided relevant information or BPM. My design is an augmentation design where it is a direct substitution. However, mods like portability and simplicity were approved or modified. Through simplicity and usability, and effectively tracks heart rate if placed onto properly. A printed heart on the wrist strap is aligned with the heart rate monitor, showing where the user has to place heartbeat sensor on. The design is learnable. Its design is simplistic, therefore it is easy to use and interact with, essentially allowing the patient / user to easily retrieve heart rate. It is a simple strap design. If applied correctly, heart rate detector component should sit on the wrist radial artery. The Pseudo code is a diagram that explains how the piece of coding provided before works. An input of the pulses is detected. If a pulse has a BPM of less than 10, it is not recorded. If a pulse has a BPM greater than 10, then the components start recording pulses and calculating the rate. Arduino kit was utilized for this project. It was used with the heart rate monitor component. The heart rate monitor had previously worked on the time of occasion. However, due to some circumstances and limitations of time of recording, the time of recording could not record the components working. Provided was an image of the setup used. The coding provided on the previous attempts had worked. This coding was collected and modified from an existing project. An LED is an addition which could be applied if specified to. The LED would light up if a pulse was greater than 10 detected. If the pulse is any lower, it will not be recorded. This allows me to conclude. Personal impact is that if it could leave patients who require attention not being able to wear the device. Design would not socially impact patient. A risk is that the patient does not know how to use the device, which could result in no vital signs. It is recommended that even if the patients have usable heart rate monitor, the nurse should not become dependent on the device and provide as much attention as possible. The device is an augmentation design, as previously said, meaning it is based off another design, however modified. Further prototyping is required. The accuracy and efficiency of the algorithms is low. Due to limitations and circumstances, the first test worked. However, the time of recording did not display LED, meaning it was not detecting a pulse, which is an issue that can be covered if more prototyping was conducted. The non-coded low-fidelity prototype of the wearable device was somewhat of a successful working design. The design had a simple strap which can be strapped off and on. However, components of the device were exposed under the wrist strap, making it uncomfortable for those who use it. Therefore, further modifications need to undergo in order to improve the device design. Thank you for listening.